Okay, so what is that? Page 427, all right? 427. All right, so let's start off with we'll do number 2 and number 4. I'm going to give you both of those. It says simplify stating any excluded values. So go ahead and do number 2 and number 4. So they want you to simplify, and then they also want excluded values. They want you to simplify, and they also want excluded values. All right, so see how you do with those. If you need to use your notes, go ahead and use your notes. Now's the time to get things figured out. Now's the time to ask questions. All right, I'm going to pause the video. All right, I know you guys aren't all the way through, and I understand that, but to get as many in as we can. So the first one, you factor out the common 2 out of the top and the common x out of the bottom. Always factor out common factors first. The first law of factoring, first law of factoring, first law of factoring. And that's all you do on number 2. Common factors out, divide out the x minus 3's, and you're left with 2 over x. And remember, x cannot be 0, x cannot be 3. Even though factors divide out, it still can't be what it was originally in the denominator. So now 4, you factor the top trinomial, 2x minus 3 times x plus 4. The bottom trinomial, 3x minus 5 times x plus 4. Again, we're too far down the road. I'll review the factoring if you want me to. Divide out the common x plus 4's. It leaves you 2x minus 3 over 3x minus 5. Nothing else divides out. From the first binomial, x cannot be 5/3. From the second binomial, x cannot be -4. If you forget how to figure out that last part, remember all you're doing is setting each parentheses equal to 0, because that's what it cannot equal. Solve the little equation, and you'll get the 5/3 and the -4. Any questions on those two? Yes, Destiny?
How come for the x cannot equal 3/2?
You saying why should it be 3/2? Is that what you're asking me?
Why is it not 3/2?
Actually, it's 5/3. That's a 5/3, and that's a -4.
No, I'm looking at the 2x minus 3.
Oh, over here.
No, the 4, number 4.
Yes.
2x minus 3.
Oh, so up here?
Yeah.
The tops have no bearing at all, because if your top is 0, you're perfectly fine, because 0 divided anything is still just 0, and that's normal. But anything divided by 0 gives you infinity, and that's when there's a problem. I'm glad you asked, because I'm sure there's a few other people wondering. And that's key, right? It's only your denominators that you're concerned about, not the numerators. Any other questions on 2 or 4? Anybody else? 2 or 4? Definitely going to see some of those. Those were on both of your quizzes, right? You had problems like that on both of your quizzes. All right, let's go ahead and do number 10. Number 10. All right, I'm pausing here. All right, so hopefully you are close to done. Right, factoring, common factor on the top. Pull out that common 3. The bottom should be a plus 2, a plus 3. Remember, make sure that your outers and inners add up to the middle. And remember, your back terms have to multiply to the back term. Can't use a -6 and a +1, or a +6 and a -1. Because +6 times -1 doesn't equal +6. All right, and then remember, you're going to change division to multiplication. You're going to invert the second and factor. And so your a plus 1's divide out, your a plus 3's divide out, and you're left with a 3 times a minus 1 over a 2 times a plus 2. If that top would have been a 6, your 2 and 6 would divide out. if the bottom would have been like a 12, the 3 and the 3 factor of the 12 would divide out. They are separate factors. You could do something there, but you can't do anything with anything else that's a quantity. Any questions on 10? Okay, so I didn't give you a multiplication one because it's the same thing except you don't invert the second part, right? I mean, same concept, but you're definitely going to get multiplication problem or two as well as division. And if you look in your book, that's loud. If you look at number 11, I'm not going to give that to you, but that's just a division problem, right? It's just the same thing we did, only instead of writing it out the elementary way with the division symbol, it's the top fraction divided by the bottom fraction. All right, and I think we've had at least one or two of those on our quizzes, so don't let that surprise you. It shouldn't be, and hopefully it's not going to be. Okay, so now let's step into the world of adding or subtracting. So why don't you try 17? Go ahead and do 17. All right, so again, I don't know how far you've gotten, but hopefully you looked at it and say, oh, I need a common denominator, right? Because we're adding fractions. In this case, the common denominator is x times the quantity x plus 1. So just because that's an x plus 1, it doesn't mean that term has an x. Remember, that x is tied into the plus 1. So you need an x times an x plus 1. And you need that on the left, so the left's got to be times x over x, and the right's got to be x plus 1 over x plus 1. Be careful on these. Here's what I find students do on these. Because we're leaving things factored, I find students tend to not finish the numerator. You've got to do distributing and multiplication of the numerators because you do have to add those numerators. So make sure you finish your top. And when you're done, you still have to look and see if the thing will reduce at the end. And sometimes it'll reduce at the end. Sometimes not, but sometimes yes. And so make sure you're looking. So in this one, hopefully you distributed this -3, right? Which gives you the -3x minus 3, grand total 2x minus 3. Again, occasionally that numerator will factor or will right away divide out with a factor on the bottom. If that's the case, finish it off by simplifying it. Any questions on that? And that was more of a simplistic one. All right, let's do one more then in this frame. Let's do number 18. Okay, so again, for time's sake, I'm just going to stop you where you're at. Hopefully you're heading in the right direction. The common denominator was x minus 9 times x plus 9. So you had to do an x plus 9 to the fraction on the left. Whatever you do at the bottom, do the same thing top. Before you had to do an x minus 9 times the fraction on the right. This is all to get that common denominator. Now you need to distribute the 8. That's the blue on the right. And now here you got to multiply the two binomials. That's the black. Now you got to add up all the numerators. And you should have gotten x squared minus 5x plus 108. And what, 9 times 12 is 108? But 9 and 12 doesn't give you a 5 in the middle. It gives you a 3 in the middle, but doesn't give you a 5 in the middle. So therefore, no need to factor or even try past that, because the 9's the only thing you can use on the bottom. So I would stop, wouldn't even bother anymore. I'm done. The 9 doesn't work. I don't need to worry about it. But I thought about it. 9 and 12, if that would have been a -3 in the middle, we'd have been in business, and it would have reduced. Okay, none of these examples have a trinomial to begin with in the denominator. I think on at least one of the quizzes we did. So that's always possible, right? You might have a trinomial in the denominator. You got to factor that trinomial to figure out what your LCD is. So be ready for that. Be aware of that. Remember, on these, you got to make sure you add up the numerators and put them over the common denominator. Any questions on 18? Anybody? Okay, so then your world changes to equations. And now with equations, though we're not going to ask you for excluded values, you're going to get rid of excluded values if you happen to come across them in your solution, right? If you find an excluded value, you're going to get rid of it yourself. So just be careful there. All right, so let's do 22. All right, again, maybe cutting you a little short. Hopefully your thoughts are, hey, I need to multiply both sides by the LCD. All right. The concept here is get rid of your fractions. If you multiply both sides by the LCD, you're going to get rid of those fractions. Now, there are two quantities on the left. And so to multiply the left side by the LCD, you have to distribute it to both quantities. Now we can divide out the denominators. If you chose the right amount, then all the denominators will divide out. You're left with 18 plus 5x equals 21. Move the 18, move the 5, x equals 3/5. What are the excluded values in this? X can't be 0, but anything else is game, so we're good to go. But you thought about it. Any questions on that? By the way, all this stuff is in your notes. You're wasting your time writing this stuff down instead of thinking. The whole time I'm explaining, you're writing. All this stuff's in your notes. It's all there. All example problems, same kind of stuff. Any questions on that? How many got that correct? Okay. All right, so be careful with the equations. Remember these, you got to go all the way to a solution. So let's try one more of these. How about 24? All right, see what we can do with that. All right, again, I may have cut you short. Hey, this one, there's actually a little trick that can make life easier. You can cross multiply this if you want. And you'll end up in the same place eventually, or you can look to see if there's an easier LCD. You can factor out a -1 out of this. If I switch the order and then factor out a negative, I get that, and I can put that negative in the top. If I do that, then the LCD is 4 times x minus 3. Now again, you don't need to do it this way. You could cross multiply, but that's going to wipe out everything on the left, and it's going to wipe out that on the right. So we end up with x squared equals just 36. And now we're ready to take the square root of both sides, and oh yeah, it's quadratic, and oh yeah, don't forget the plus minus, and you get plus or minus 6, and you got to say to yourself, are both of those values okay? Yes, because the excluded value is just when the x is a 3. And so only 3 wouldn't work, 6 is fine, and away we go. That was the easiest way to do the problem. Again, if you cross multiply, you're going to end up in the exact same place, though. And this one isn't even bad to cross multiply. It's not that bad. You end up in the same place, and you'll be there. Any questions on that? So equations, make sure you take them to a solution. If it's quadratic, it's quadratic. Then you got to deal with it that way. Okay, we're not going to have time to do this next problem, although I'm going to do it. Look at 28. Read it as I read it. Debbie can set the tables for a banquet in 32 minutes. If Malika helps her, they can do it in 14 minutes. How long would it take Malika to set the table by herself? Do you remember how to do these? Do you remember that they're reciprocals? So 1 over the 32 minutes for Debbie plus 1 over, I don't know what Malika is, so she's X, equals 1 over the total, which is, in this case, 14 minutes. All right, if there were 3 people, then there'd be a third equation on the left, right? The right is always 1 over the total. If there were 4, there'd be 4 fractions on the left. I said equations, fractions on the left, and the total on the right. So again, eliminate the fractions, find the LCD. In this case, it's a pain. You got a 2 and a 7 with a 14 and 32, what? All kinds of 2's. So again, once you figured it out, you'd multiply the left by the LCD, the right by the LCD. If you wanted to even save, this one might save you time if you just do 32 times 14 so that you can wipe those out there. And yeah, I need my X. And you can wipe out the X there and the 32 times 14 instead of bothering to figure out the LCD because the numbers are a pain. And so where would you end up with? You would end up with 14x plus whatever 32 times 14 is there equals, I forgot my x again, 32x. So move these to the other side. What is that? 18x equals 32 times 14. Divide it by 18 and you're there, right? Again, hopefully you know how to set those up. 1 over, 1 over, 1 over if there's 3. Equals 1 over the total. Multiply by the LCD. Voila, you are done. All right, I want to look at 32. This one says, identify the asymptotes, point discontinuities, and intercepts for each function. Just going to do the asymptotes and the discontinuities. So I'm going to do this one. Why don't you just watch instead of writing? It's in your book. You have odds that you can do as well. So look, here's the basic problem. I'm going to factor the denominator. Okay, I need a positive in the middle, and I need a positive 1, so positive 3, negative 2. That gives me the middle, and that's the correct factorization. So the x minus 2's divide out technically. All right, so what would be the asymptotes on this? Just the x equals negative 3 is the vertical asymptote, right? The horizontal asymptote in this case would be y equals 0. I'll get into that in a minute in the other example I'm going to do. What about the point discontinuities? Well, because this divided out, it's not an asymptote, but it is a point discontinuity, and x cannot equal 2. This is the asymptote. This is a hole in the function, just at that one little spot. So technically, if you were graphing this thing, when you were coming down like this, wherever 2 was, technically there'd be a hole there. I wouldn't continue the line. I would actually draw it to the hole and then continue from the hole. That's the idea. All right, so let's do one more thing in this kind of realm. Let's look at 36. I'm going to modify it just a bit. So this is kind of 36, but I'm going to modify it. So let's stick with 2 over x plus 1, but let's make this like minus, 17 for the fun of it. Okay, can you tell me the center point? Can you tell me the vertical and horizontal asymptotes? So x equals what and y equals what on the vertical and horizontal asymptotes? Can you give me the domain? Can you give me the range? Can you give me all of that from that function? I will ask you this tomorrow. Just telling you right off the bat. So can you determine the center point? Can you give me the vertical asymptote, x equals whatever? Can you give me the horizontal asymptote, y equals whatever? Can you give me the domain? Can you give me the range? I don't have time to go over graphing, but if you're going to graph, you definitely want to know the center point and the vertical and horizontal asymptote, right? So Domain and range, no big deal, but the first three you definitely want to know. Center point, and you want to know the vertical asymptote, the horizontal asymptote, and then XY chart to finish it off, right? So what's the center point? -1, -17 is the center point. Remember again, this is x minus h plus k, right? So because it's x plus 1, it's actually a -1. Okay, so what is the vertical asymptote? X equals -1. What's the horizontal asymptote? Y equals -17. That's not hard. And you get it from your center point. Who can give me the domain? Domain. Dolores? Yeah, the set of all x's such that x... Correct. Set of all x's such that x does not equal -1. So again, if you were to graph this thing, and this is just going to be a sketch because our asymptote is way down here at -17, and the other one is at -1. So basically this thing is spraying like this. Top is positive. If it were negative, it'd go the other way. Basically like that. So what are all the x values? Everything except the -1. And what's then the range? The set of all y such that y does not equal -17, right? It all comes from the center point because, again, what y values can't you have? And that's that one, the -17. Any questions, anything about the test? Luke.
You're gonna ask us about